Hey, Cloudcast community, listen up. Today's show is sponsored by Datadog, a cloud-scale monitoring and analytics platform. Datadog was built to bring clarity to complex, dynamic applications, whether they're in the cloud, on-prem, in containers, or wherever you run your applications. With powerful dashboards, seamless integrations, and more than 250 technologies they can monitor, Datadog has you covered. Whether it's AWS, Azure, or Google services, your popular open source projects and products, or web security and APIs, Datadog can help you monitor them and help you collaborate around troubleshooting them and make sure they're running great. Datadog provides deep end-to-end visibility into the health and performance of modern applications. So, try it yourself. Get yourself a free 14-day trial. Go to datadoghq.com/cloudcast. That's datadoghq.com/cloudcast to try out your free 14-day trial. And if you try it out, let them know your friends at Cloudcast sent you, and they'll send you a great, wonderful, soft, awesome t-shirt with the Datadog logo on it. I wear mine all the time. So once again, that's datadoghq.com/cloudcast. Thanks for listening, and here comes the show.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. You know, we're following up from the news from Google Cloud Next last week. We sort of hit the show and the timing of the show right after the first keynote from Google Cloud Next last week. I know we talked a little bit about the Anthos announcement, Google Cloud's planned hybrid cloud offering or multi-cloud offering. And we really didn't get a chance to dive in anymore. And so we thought this week with Cloud News of the Week, we would touch on one other topic that came up in the Google Cloud launch, the Google Cloud Next event that was launched that will be something that I think we're really going to probably dig into a little more throughout the year. We've touched on it a little bit, but we think it's going to be something that's going to be going on, more and more. And that was Google made an announcement around open source, and not so much a new open source project, which they've done in the past. Kubernetes was launched and so on and so forth, TensorFlow and other things. But they made an announcement around partnerships around open source. And this was an interesting announcement, especially in the light of the open distribution of Elasticsearch, which AWS had announced a few weeks back. And really, there's been a lot of things going on in the open source world in terms of the companies that are the commercial distribution of some of the really popular open source technologies are trying to figure out, what the world now looks like when the major cloud providers are offering services with that technology, and how do they compete? How do they monetize? How do they avoid getting sort of taken out and so forth? So this was an interesting announcement by Google. In essence, what Google said was a couple of things, and there's still quite a few details that really weren't disclosed, at least disclosed in the press releases and the blogs and the announcement, but we'll be digging into it more as we go. The basics of it were Google is planning to host a number of managed services from some of the popular open source projects. Primarily, they were focused around database services. So the 6 or 7 that were mentioned: Confluent, DataStax, Elastic, InfluxData, MongoDB, Neo4j, and Redis Labs. So those 7 were announced as services that Google is going to run and manage. And, bunch of integration back into Google Cloud Services. So IAM, billing, performance metrics, monitoring, logging, all those types of things. And it's really interesting. There was some sort of between the lines things that you could kind of read into this. In essence, what they were saying was they plan to partner with these companies. This is not Google just doing this, taking pure open source. They're working directly with these companies. And there was sort of, without explicitly saying it, there was sort of an implication that there would be some revenue sharing that may happen at some point in this partnership. It wasn't explicit there. They didn't get into the details. We're going to be digging into it some more, but that was very, very interesting. It was essentially Google saying, hey, we want to be a safe haven for for open source projects, companies that are trying to commercialize open source. So it'll be very interesting to see how this plays out. Obviously, they picked 6 or 7 database companies to begin with. It would be interesting to see if this extends to other projects that are out there, whether this is, things like Chef and Ansible and Puppet, or, other types of major successful open source projects that are out there as we go along. So thought that was an interesting one to sort of dig into. Obviously, we'll put it in the show notes. It will definitely be interesting to see how all the different cloud providers begin to respond to this. Because the other thing about this is, for most of those companies, and this if you've been listening to our ads, people like MongoDB run their own service called MongoDB Atlas. Confluent has the Confluent Cloud. A lot of these cloud providers a lot of these open source companies have begun to have their own cloud services because they basically realized they wanted to maintain direct contact with their customers. So it'll be interesting to see how all of these things play out from the open source project and the communities, licensing evolving or changing, the different cloud providers having these direct offerings themselves. Do they do them directly? Do they do them in partnership? Do they create forks of projects? Really a lot of things going on in open source these days, and everything from the projects themselves to licensing to the cloud services to the partnership around cloud services to monetization. So a ton of really interesting things happening in that space. We thought we'd dedicate an entire Cloud News of the Week to it. So with that, we really we're thankful, as always, to our sponsors, both MongoDB and Datadog, for sponsoring the show each week. Really appreciate it. And coincidentally, we're going to talk a little bit with InfluxDB, InfluxData, about time series databases. So we're going to dig into that with our interview next. Today's Cloudcast is sponsored by MongoDB. As a software engineer, chances are you've crossed paths with MongoDB at some point, whether you're building an app for millions of users or just figuring out a side hustle or a new project. As the most popular non-relational database, MongoDB is intuitive and incredibly easy for development teams to use. Now, with MongoDB Atlas, you can take advantage of MongoDB's flexible document data model as a fully automated cloud service. MongoDB Atlas handles all the costly database operations and admin tasks that you'd rather not spend time on, like security, high availability, data recovery, monitoring, and elastic scaling. So go try MongoDB Atlas today. You can visit mongodb.com/cloudcast to learn more. And we're back. Folks, one of the things that we found last year in terms of topics and so forth was there was a tremendous interest from the audience around database technologies. And while database technologies are very interesting, and we've seen them evolve quite a bit over the last few years from lots of depth in relational databases into this explosion of new use cases, we thought it would also be interesting to not just dive into a new technology, but really look at what's the business impact? What are business decision makers thinking about some of these new technologies? And so with that, we're very excited to have our guest today, Evan Kaplan, who is the CEO of InfluxData. Evan, welcome to the show.
Thanks, Brian. Thanks for having me.
So you've been CEO of Influx for a couple of years now. There's a really interesting post that you have out there that talks about how you came to the company, how you met the founders. But for folks that may not know either yourself or Influx, give us a little bit of your history, because it's fairly rich in terms of the things that you've done in your background, and then ultimately what brought you to this domain space and to Influx.
Yeah, that's great. Thanks for the question. So my background is broadly defined across multiple parts of the tech stack over the years. And so probably where the story gets interesting is I joined a networking company in 1990 that was doing some of the first TCP/IP stacks on PCs. And so I developed a fair amount of expertise on networking and early technology. And then I started a company out of my house in Seattle in 96 called Aventail. It was the first SSL VPN company. And that grew quite large and then shrunk quite a bit when 2000 burst and then grew it again. And we were able to sell that to Sonic Wall and Dell in 2007. And then I moved to the Bay Area to run a public company called iPass, which specialized in global Wi-Fi and connectivity for enterprises. And so again, more on the networking and security technology. And we broke that company up, and then eventually part of it remained public, and then recently it was sold. And during the break, I took a seat at Trinity Ventures, the investors I knew, and I got to look at a bunch of different new companies. And that's where I first met Paul Dix, the founder of Influx. First of all, Paul and I hit it off really well. Paul's a really exceptional technologist. He's also a brilliant guy, and we just connected on a bunch of levels. Having been an entrepreneur and taking a company from zero to something of significance, what that emotional journey was like was really important for us, and we bonded a lot around that. And so I helped him for three or 4 months as they were sort of building their first products and technology. And then he asked if I would join as CEO. And that was in January of 2016. So it's been 3 years now. And I'm not by nature a database expert. That's certainly not been where my career has gone. And it did take me a while to learn this world. And I think it is. And Brian, you started in networking also, and so I think in the networking world, it's kind of relatively easy to understand how these technologies come together if you understand the OSI model, the 7 layers, and how all these things play and where you play at each layer in the stack. And it's a very good formative model for understanding a business. The database world doesn't have any such thing that looks like that.
Right.
And I find it, it's a series of abstractions. So coming and learning that business, obviously Paul was tremendously helpful and the team. But when I started, we were about 25 people. We're now at 140, and we'll probably exit this year closer to 220.
Wow, that's outstanding.
But it's a long way to answer your question. Why I joined was, 1 was my bond with Paul. 2 is I really felt like this was going to be a truly interesting space. And 3 is from an open source perspective, as a CEO, I'd used a lot of open source technologies. But one of the beauties in these early stage companies of an open source technology is you can see how your users are using the project. And in this case, it was InfluxDB. And having that visibility early on in a company's lifecycle is so tremendously powerful. You could see very clearly what the use cases were and what people were doing. And for a sweatshirt or a T-shirt, they would send in a testimonial. And it was just very helpful in figuring out how to grow the business and how to grow the platform.
Yeah.
Sorry, long-winded answer.
No, it's great because I think, it highlights a couple of things. Obviously, like you said, you're transitioning between technologies. There's some learning curves that go on, but from a leadership perspective, we're in very interesting times in terms of the competitiveness of markets, but also just the way people are using technologies to impact their business. And it's just as important to understand the technologies, but it's also important to have people who have been through good times and bad times, and understand that you take actions, you make decisions differently depending on what's going on. So having that experience, I'm sure, was incredibly valuable to the founders, and it's good that you're there.
It's been a great place to be.
Yeah. So I highlighted it in the open. Databases have changed. You mentioned it. There's not really kind of just one stack for databases. InfluxData really focuses on time series databases as the core of what you do. Can you talk a little bit for people that may not be familiar with time series databases versus other types of databases? What are some of the things that they do uniquely well, maybe from a technology perspective, but more importantly, what are some of the kind of patterns and business use cases that people are selecting time series databases for to make them successful? Sure.
Maybe a good way, and you can cut me off if it's a little long-winded, is to answer your question is to just talk about what's happening in the database world. Sure. And why this is even relevant. So, if we go back, in the industry 20 years ago, you had your choice. There was Oracle, there was DB2, and perhaps Sybase or Informix, right? For virtually every single database application. I don't know the exact numbers, but I'd venture to say it was 95% of the database market was some sort of relational database. And open source wasn't a thing in that way back then. And then I think if you go back 10 or 12 years ago, you see MySQL and then Postgres have a very big impact on the database world is the notion that you could use another database besides Oracle or even Microsoft SQL Server. And that opened up whole can of worms. And as you think about this over a long haul, what you see is the breakup, a couple of things happening. One is the breakup of that huge franchise, which is Oracle, old IBM stuff, right? As new databases, new applications get built into these increasingly specialized silos. And at the same time, you see the dramatic increase in data, period, right? Just through the roof. And so what's happened over the years is you see, from MySQL, you see things like Cassandra and HBase, which are really targeted at distributed databases, and SQL and NoSQL. You start to see Mongo emerge, whose primary benefit was as a document data store, and that becomes a category to itself. You see Neo4j emerge as a graph database. You see Solar, then Elastic, arguably Splunk emerge as a search database. And so you begin to see this kind of fragmentation in which, to use the old English term, you see horses for courses, if you will.
Right.
Things that are built specifically for purpose. And I think Paul's true insight back in the day is Paul is a developer's developer, if you will. He really cares a lot. He ran the machine learning meetup in New York City for 10 years. He ran the Ruby on Rails meetup. He really cares what makes developers productive. And that's core to our brand, this notion of a time to hustle. And what Paul saw was that everybody was writing time series. And if you wrote time series stuff 20 years ago, you wrote it on Oracle. And if you wrote it 10 years ago, you wrote it on MySQL. If you wrote it 6 or 7 years ago, you wrote it on Cassandra or HBase or something like that. And his experience was, this is just really freaking hard. You end up tilting up this expensive, distributed, not optimized infrastructure and writing a bunch of application code to handle metrics and events at scale. And it's always suboptimal. It's always expensive to maintain and takes development. So his insight was build something that is purpose-built for time series, right? Build something purpose-built for collecting metrics and events and make it, give it 10 minutes for a developer to spin up an instance, collect the data, make it schemaless so that people could be super flexible in how they approach it, and just allow developers to sort of unlock that power. That was his insight.
Right.
And so to answer the question, the long-winded answer to the question is what makes a purpose-built time series data? It's a couple. There are 5 or 6 things that are super important. The first is obviously you have to be able to ingest data at pace. And really, we're talking hundreds of millions to billions of points a second. And I'll talk about the use cases that kind of drive that, right? And so huge, fast, super write. And you can do that because the data is largely structured. It's timestamped data. You know what kind of data it is. You know that. Secondly is you generally want to alert, alarm, or build control systems on that data. So you have to have a powerful continuous query engine so that you can basically build control loops. So if something is out of band, you can quickly put it back in band, if you will. And so that became important. How many continuous queries can you go at a time, and how quickly can they resolve, and how real time can you do all that sort of stuff? The third thing is if you know it's a time series data, you should be super efficient in compressing and storing it so that people can keep that data if they want for long periods of time. And then the fourth is, and this is the counterintuitive thing for databases, is you have to be able to evict that data super fast. So you can imagine, say you're connecting, and I know you're familiar with this, data on the performance of a Kubernetes cluster or a series of containers and things like that. And you want to keep that data around for 30 days. Mm-hmm. After 30 days, you're evicting as much data as you're ingesting. And most databases aren't built to evict data.
Right.
They're built to hold it. And so you have to build a model that allows you to evict data at pace. And then the last point is, for that kind of data, is often, say you're managing that Kubernetes cluster or that series of sensors, you want to downscale that data or downsample it, right? So you could say, listen, I want to keep around 100 millisecond increments if it's network data for 10 days. And after that, I want to downsample to seconds. And then for long-term storage, I want to downsample to 10-second samples so that I reduce the storage load. That is a common use case. High-resolution data in short periods of time, and over long period of time, lower resolution data. So the platform that we started building with Influx was designed to handle that kind of traffic and that kind of load.
Yeah. No, that's an excellent description and sort of checklist of, like you said, you could do time series back in the day on kind of non-purpose-built databases, but at some point, when you're, like you said, you're thinking about how do we get developers productive right away? How do we deal with sort of these new models where everything is spitting out data all the time, or like we'd like it to? And then, like you said, there's going to be some counterintuitive things that maybe you didn't do with an old database that make a lot of sense now because while it's great to collect a lot of data, at some point, it does become cost prohibitive to keep all of it forever, and you may not necessarily want all of it. So, yeah, no, that was an excellent kind of overview of what people are doing. What are some of the, kind of use cases, business level use cases, things that people would tangibly go, oh, okay, that's what they're doing with time series that you see from your customers?
Yeah, it's also a really good question. And so there are really two broad, and I saw this from the first time I was engaging with Paul in late 2015. There are two broad, and I call them above use cases, but the use cases drop down a little, but let's start there. There are two broad things that are going on. One is the instrumentation of the physical world, right? And one way to think about it is the sensorification of everything physical. We've known this in the network world for years, right? Because our devices have always been connected, but our homes, our cars, our healthcare, our clothing, from the consumer world and in the industrial world, virtually everything that has a process, right, is being connected physically by sensors, and those sensors are reading off. And so about half of our business is tied to that, literally collecting data off a sensor. So
gotcha.
Tesla's new power walls are instrumented with Influx so that you can see how much power you're generating or consuming on your phone using Influx. Siemens windmills are with Influx. Nest devices are all that data is being, not all of it, but a lot of that data is being captured in Influx. And so you find yourself you can see those obvious use cases in the physical world where data is coming in off of these hardware devices. It's telling you what's going on. It's being stored in something like Influx.
Yep.
That's one. The other side of the equation is the virtual world, which is a little less understood. But you would, because of your background in the Kubernetes space, would understand acutely, which is there's really fundamentally no difference in the time samples between the physical world and the virtual world. And so if you think about this next generation ephemeral stack, VMs, containers, microservices, virtual networks, applications, business processes, all of that needs to be instrumented. It wants to be instrumented in real time so that you can see it for observability purposes. And it wants to be instrumented smartly so you can build either control loops around it or at least, do deep analytics around it. And so the second, about 50% of our business is in that world, the software world. So it's everything from network monitoring to Kubernetes monitoring to deep microservices. So companies like Wayfair, IBM's cloud service, SAP's Ariba, and Hybris platforms, they're instrumented with Influx to get a real-time read of what's happening in that infrastructure. And the drivers there are this movement from monitoring and logging or forensic-based view of their systems to an increasingly observability and a real-time view of the systems.
Interesting. Yeah, no, that makes a lot of sense. And I know we've had a number of companies who have come on that are in that physical space. And you mentioned windmills and you mentioned Nest, and we've had people that are building farming sensors, people that are building light sensors for municipalities and so forth. So you start talking about those types of numbers, they actually start to dwarf kind of what we think of as traditional IT in terms of
sure.
number of devices and how much data they can spit out that you wouldn't necessarily have thought of. So a lot of times we will sometimes go a little bit deep on technology topics. Influx has a very rich technology stack, but I thought, given your background, especially on the business side, it might be good to pick your brain as to, what does the business side conversation sound like, when you're talking about maybe not databases at the database and schema level and so forth, but as you're talking to business leaders and they're saying, hey, this is how we see the business evolving. These are some of the key things that are going to impact how we compete. How do you translate that conversation into, why time series is the best choice for them? Because, that decision, your database decision, at least in a lot of cases, is a platform level decision. It's a long-term decision because it's where your data is going, data gravity. What does your conversation sound like with another CEO in terms of translating the business needs or where they want to go into these sort of deep down technical decisions?
Well, it's just sort of funny. It's like if you were to go to like a cocktail party and you were to say, people ask what you do, and you say time series data, you can watch their eyelids slowly fall down, and they fall. Right. Because it sounds like it's such a deeply technical. And the truth is the technical part is super important to us because developers are the ones who bring our stuff in, being open source, architects the one who design around us. And it's really, the technical part is really important.
Right.
But the broader story I have with another CEO or CIO or even a CTO goes something like this, which is, listen, we're living in an age of, let's call it an age of instrumentation. This sensification of the physical world's obvious to us all. We're seeing more and more of that sort of stuff. And you can start the easy metaphor there is self-driving cars, right? Increasingly smarter systems, machine learning, all those sorts of pieces. And what my clarity about that is listen, in order to build more sophisticated, smarter systems, you're not buying off-the-shelf software products to do these things in the same way. What you're doing is you're going on a journey, and the journey starts with instrumentation. So let's make it up. I built this new thermostat, and it's in 100,000 houses, and it's collecting all of this data. And what I want is the system to be smarter and smarter and smarter to eventually so it's autonomous. In order to do that, I run a cycle. I instrument, I observe, and I observe in real time. And that's the difference, right? I observe in real time. And the reason why I want to observe in real time is because I don't fundamentally know how the system's going to behave until I watch it in real time. I then make changes. And this is now done via software, often via CI/CD. Right? So you're constantly seeing software changes. I then instrument further, I observe again, and I build a control loop. And then I do this cycle. And if I do this a couple of million times, I may arrive at a self-driving car. And all systems, and all their systems, all your operational systems, if you're running a company or all your software systems, they want to get to the point of being autonomous. It's not the point that they get there. It's the point that they want to get there.
Yep.
And in order to do that, you need to be able to collect, you need to become a data nut. And you need to be able to say what happened, to eventually say what's going to happen. Time series is the foundation for that. You want a common place to store that data. You want to be able to work with it efficiently. So that's kind of the high the story is you can't even begin the journey to have smarter either physical or virtual systems until you've instrumented and collected on a time series platform, whether ours or somebody else's.
Yeah, no, I like that. It's kind of the same conversation I have with people. People know I work on Kubernetes in my day job, and they laugh sometimes because I'll tell people like nobody's business ever wakes up and says I have a Kubernetes problem, but they go, hey, I'd like to have highly automated, scalable environments and make my developers productive. It sounds like it's very much the same thing for you, and I like the phrase. It's the age of instrumentation, and that ultimately allows some of these new things to be possible, but they're not going to happen immediately. You've got to collect a lot of data. You've got to be able to look at it, like you said, in real time. There's got to be real-time feedback loops. And I like that ability to say that's how you get to what it is. It does a good job of connecting, the business problem with, the underlying technology.
Yeah. It's not a sexy idea, but increasingly in developer circles, like you write your code, it better be able to report out. Right? You better be able to have great telemetry on anything you're writing. So starting from the very ground up, telemetry becomes really important. And that's become to the forefront even in the developer world, and it's certainly a forefront in your world, in the container world.
Right.
Right.
You mentioned developers. More and more, especially with open source, as you mentioned, developers have a lot of choice. Their choices are becoming easier to get started with. Maybe not necessarily easier to choose between, but it's easy to get something started. What are some of the things that Influx has found has been useful and successful in getting? Number one, getting developers to say, okay, I'm going to use purpose-built time series, and then more importantly, to adopt your stack is, what are the, getting developer attention is difficult. What are the things that you've done to be successful? Because you guys obviously, you continue new rounds of funding, but what are driving developers towards your platform?
I think at this point, if you look at, we're at the point now where there's starting to be an understanding that we need something like a time series platform. And then if you look at some of the common indexes, we're clearly a leader by a wide margin. Mm-hmm. That just puts more pressure on me to make sure that we don't drop the ball.
Sure.
And so we get some benefit just by being the brand associated with time series. So we get some benefit from that. But the real benefit comes when we can get a developer in the open source to download the platform or use our sandbox or spin it up in our cloud, the experience of being able to do something of import really quickly, like, literally 5-10 minutes max, where you can dump your stock portfolio, you can measure the smart stuff in your home, your electrical use. And so you begin to see the power of it. A huge portion of our enterprise growth comes from people who started out using it as just developers at home, as just to play with it, to go, this is really easy. Wow, this is a powerful thinking model to organize this data. And we've been able to, it's a lot of work to stay in front of it in terms of scale and horizontal scaling out and building tools to integrate with a variety of different systems. And there are 200 different collectors that support all that. And so what you want to try to do is become the default choice in that world. Yeah. And so we're trying to do that. Now, obviously, there are going to be good companies competing with us. So I'm sure we don't have it to ourselves.
Right. Absolutely. I want to wrap up with one last question. This kind of is in parallel to developers having choices. Customers, have a lot of options now in terms of maybe where they're going to run their platforms. Do they want to run their own software? Do they want to consume something from the cloud? Influx has a broad portfolio of ways that people can consume it. Obviously, somebody could take all of the upstream open source bits and put together the tick stack, which I've learned about here recently. Sort of all of those pieces. Obviously, you sell a commercial version of it, put together, fully integrated value around that, and then you offer a cloud offering as well. How have you seen the market, kind of adopt to all those different models? Obviously, they're interested in all pieces of it, but what's been the kind of decision criteria for people to run it themselves versus consume it as a cloud and maybe move between them?
Yeah, that's a good ending question, by the way. We were in the beginning, our monetization on the cloud was relatively meager. This last quarter, it's about 50% cloud, 50%. I'm sure 50% they take the software license themselves and they run it. My view, it goes something like this, is that increasingly people will want to consume it in cloud native. And what I mean by that is, Kubernetes is involved here, is a multi-tenant, API-driven, serverless model where they can consume as much as they need in real time, much the way you'd buy a Cardinal database service on Amazon or something like that. That, I think, is where all of us need to go who build these kinds of platforms. And we're in private beta with our cloud native stuff. It's taken us over a year to decompose this tick stack, build it on a Kubernetes backplane, and we're pretty excited about it. We think it's a really important intervention. But I think the best open source companies offer sort of the diamond level is you're able to do multi-cloud. And so you have an offering that can run on anybody's cloud and does run on at least the 4 major clouds.
Yep.
2 is you have an on-prem version that people can run for what I think is likely to be the 20% of the market who will continue to want to run it on their own premises or in their own private VPCs or things like that. And 3 is that you have an open source offering so that developers can engage with it, they can use it, they can even run it without paying you a dime. I think that's the diamond level of offering. I do perceive that 80% of the business over a long period of time will be in a cloud-native SaaS environment.
Yeah. No, I would agree with that. And I think it's becoming more and more important that, the companies that, at one point were software companies or part of open source communities are emerging to become maybe not full-blown cloud providers, but offering cloud services. If for no other reason, then you better not only make great software, but know how to operate software because
right.
Your customers don't want to do it, and you need to understand how to make it better, make it run. It's very cool to see that emerging so quickly from so many companies. Listen,
well said, Ryan. I totally agree with the way you said that. You don't just make software, you know how to operate it.
Right. Well, listen, Evan, I want to thank you for the insight today. It's been very helpful for folks that, want to learn more about, time series as a technology or InfluxData in general. What are some of the good ways for folks to, to reach out maybe beyond the website, upcoming events you're going to be at or other things?
Yeah, so we run an Influx Days in London. That's coming up in June. And we show up at most of the DevOps days around the world, and we'll be at Google next week.
Okay, excellent. So, very, very good.
Yeah.
Well, very cool. Well, listen, again, thank you so much for the insight. We learned a lot. I know the audience is very interested in this. And, like we said at the top of the show, there are so many new business models that are emerging, so many new use cases that are emerging that, real-time use of data and sort of analytics on top of it is going to be so important. So really appreciate it today, folks. As always, thank you for listening. Thank you for telling a friend. Thank you for rating the show on iTunes and other places. And with that, we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.